Hey there everyone. In today's video, I'm going to show you how to plot longitude and latitude coordinates on the maps. Specifically, we're going to be using Folium maps. There's a few different maps that you could use for this task. I'm picking Folium maps. I like that a lot. Plotly maps would work just as well, I assume. And we're going to track truck routes. We're focusing on utility trucks. It could be any kind of vehicle. It could be a car rental from Hertz, from I don't know, like what a car rentals enterprise, any kind of truck that is utilized for some type of service purpose, utility trucks, car rentals, maybe even moving trucks, right? That's another option. U-Haul trucks, something like this, right? There's so many applications for this type of thing. So as long as you have a real-time GPS system installed on the vehicle, you can do all kinds of things like obviously real-time tracking location. If the truck gets stolen, you can identify it pretty quickly and easily. Route optimization, performance monitoring, even calculate maintenance scheduling and be proactive about scheduling before the vehicle breaks down. You know it has so many miles on it. You know where it's been. You can preempt the breakdown and do the service before the vehicle is hundreds of miles out in the middle of nowhere and broken down. Then you have to send another vehicle to go get it, right, and rescue those guys. So any kind of compliance and monitoring, customer service, proving that the truck went out to the customer site and performed the task that was assigned to it. So you have validation there. Incident management, historical data analysis, safety, security enhancements, any kind of compliance regulation. So lots and lots of applications for this. So we are going to look at a plot of 10 different trucks that drove around, presumably delivering, well, these are utility trucks. It could be an Amazon truck doing deliveries. We're focused on utility trucks, driving around in a 24-hour period, okay? And the intervals are going to be 1-minute frequencies, so pretty realistic. I used to work for a utility company, and this is exactly what we do. We captured the GPS data. It was always stored in JSON format, so we could go into a web server, extract it, and explode the JSON and get it normalized into a data frame and do some analysis on it. Like look at distance traveled, look at incremental distance traveled per hour, per 24-hour period, weekly durations, monthly, things like that. You could plot and chart all the data, of course, so very, very useful stuff. So we have a couple libraries that we have to import here. Folium for our maps. Folium has many libraries embedded in it. It's a pretty powerful tool. It's been around for a while, so it's pretty evolved. It's pretty mature at this point. So we're looking specifically at timestamp GeoJSON. There's all kinds of heat maps and what else? You can do all kinds of clustering using Folium maps. I have a couple videos coming out on that soon, so you can keep your eyes out for that. So I'm going to go ahead and create some data. It took me a little while to figure out how to do this, but I don't have access to any kind of GPS data. Typically, that's going to be confidential and very specific to the business, and there's no way I would have that or no way I should have that. So I'm going to create some hypothetical data that's pretty realistic, and it's going to basically represent the GPS data that if you worked for this company in this capacity, again, it could be Amazon, Hertz, some kind of utility vehicle rolling out to a service site to restore power if there's a power outage in some neighborhood. So there's many applications. You would just use your specific data. I'm trying to make this example generic as possible. So you can take your data, copy and paste it in here and run with it, okay? But since I lack the actual GPS data, I'm creating it. So let me go ahead and hit Control Enter in my Jupyter notebook here and refresh it. And by the way, the code and business logic here is a little bit convoluted, but don't get intimidated by that. It's pretty generic. You just have to import your data into here and then run the analysis on that. And I'm going to save this notebook down as an HTML file, and I'm going to post this when I post the video. So you're going to have access to all of this code right here. You can basically copy paste that into your Jupyter notebook, substitute your specific data for the hypothetical data that I'm generating here, and you should be good to go, okay? So let's see what's going on. We created the truck movement. We have the lat long coordinates. We have the increments of 1-minute frequencies, okay? And we are plotting all this on the map. So let me go down, see what it looks like, okay? We are kind of looking at the southwest here, more or less southwest. Yeah, pretty much. Okay, and here's the routes plotted on the map. So I picked some different locations based on somewhat random latitude, longitude coordinates, just to illustrate the point. Again, I don't have access to this data. So let me zoom in here just a little bit. This is what, Southern California, or maybe Central California. I think this is Central. So these are all the routes that this truck drove on in the past 24 hours. Great. Probably doing some drop-offs of equipment, pickup of equipment, maybe some checkups on some transformers, things like that. Again, we're focusing on these utility vehicles. Okay, and let me go down and look at another path of another truck. We had 10 total. Okay, so here the range on this guy is a little bit tighter. It looks like the green truck kind of drove a little bit more linear, and this guy kind of went back and forth in a zigzag pattern. And that raises a question too, like, is this what they're supposed to be doing, or is this not what they're supposed to be doing, right? So not to point the finger at people or to get them in trouble, but this gives yourself and myself and the data analyst, the data scientist, and so on and so forth, evidence of where the truck has been, right? So this is a fingerprint. This is proof of where the truck has been. As I look at maybe 1 minute intervals are a little bit too frequent. Maybe we need 5 minute, maybe 10. It's really up to you, and then how you want to capture the data. But there's all kinds of variations and all kinds of different things you can do with these maps. Okay. And then if I zoom out, we can see some of the other truck routes. I think I saw one in Colorado, one in Utah. Okay, let's just take a quick peek at these over here. Yeah, Utah has a couple. Okay, my computer's a tad bit slow here as it refreshes. Been working this thing pretty hard today, all day, so maybe we'll power down soon and give it a rest. So again, same concept. The truck is driving around, doing what it needs to do. I think, when you get 1 minute intervals, maybe that is too high frequency. Maybe you just need 5 minute or 10 minutes, something like that. So that's why you see so many dots here. But again, I think this is a pretty realistic scenario of what you would have with your own GPS data. When I used to work for a utility company, this is pretty much what we'd have. It was very similar to this. So very relevant. So let me go down just a little bit more. Again, I'm going to share all the code with you, so you don't have to understand all the nuances, all the details. You can copy paste this into your own Jupyter notebook, run it as is. You should be good to go, and then just take some time to get acquainted with the logic, understand how it works, peel back the layers of complexity a little bit, right? And just experiment. Just change some of the parameters, see what the impact is, and learn from your mistakes. Of course, you can make mistakes. I've been doing this for about 11 years, give or take, maybe going on 12 soon. And God knows I made my fair share of mistakes. I made tons and tons of mistakes, but that's how you learn. You don't necessarily learn from your successes. You learn primarily from your mistakes. If it's successful, you just move on, right? If you make a mistake, then you have to dig in deeper and see what's not working, right? And then figure it out. So that's fine. So Control Enter to refresh this cell, and we'll see what we'll get. So I always like to refresh these just to illustrate the point of what's happening, and just so people know, okay, and just copy and paste some image, and this is some kind of like fake thing. This is really definitely real, and this is running in real time too. Okay, so here we are looking at a similar type of analysis, but now we're looking at the total distance that the trucks drove, as opposed to plotting the distance on the map. Okay, and there's all kinds of things you can do with this. This is total distance. You can do distance by hour, by 12-hour increments, whatever frequency you think suits your use case and whatever is beneficial for you. This is just a generic example, again, capturing the total distance over the 24 hours that the trucks are out. But again, it gives you a good estimate of which trucks are driving more, which trucks are driving less, which trucks will need higher frequency maintenance and which will need lower. And overall, just understanding like the details of the truck, what the truck's been through, where the crew is going, what they've been up to, and you have evidence for all of this stuff. So it's pretty cool to be able to get the GPS coordinates, plot this on the map, and see firsthand like exactly what's happening, right? So in conclusion here, GPS fleet tracking helps companies keep tabs on their vehicles. Okay, I think I said that before. It also helps with reducing fuel waste, improving maintenance practices, monitoring drivers, but in a good way. You don't want to be Big Brother and, checking up on guys all the time. But, if somebody, deviates from the path over and over and over again, you might want to have a meeting with the crew, right? Like you want to make sure that they're doing their job and that they're staying on point with that. So I think that's it. Tons of stuff to learn here. Thanks for tuning in today. Hopefully you've learned a couple new tricks here. Thanks for your time and have a great day. Bye.